Here in this problem, we need to check whether if the 3 points ABC whose position vectors are given are collinear or not. Okay, let us begin. So here, let us suppose that we have 3 points, point A, point B, and point C. And we are going to consider an origin O. This origin is going to be the origin of some coordinate system. Now, with respect to this origin, we can define the position vector of A, B, and C. All we have to do is join O and point A, O and B, O and C with the help of a directed line segment going away from O. So here we will assume that the position vector of point A, which is defined by OA vector, let's say this is given by the vector A vector minus 2B vector plus 3C vector. Then we have OB vector. OB vector will be defined by the vector 2A vector plus 3B vector minus 4C vector. And then we have the position vector of point C, which is going to be defined by OC vector equals to negative 7B vector plus 10C vector. Fine. Now, what we'll do, we'll try to find out the vector AB. To find out the vector AB, all we have to do is take the position vector of the endpoint, which is B. So we have OB vector, and from it subtract the position vector of the initial point. That means point A. So we will try to find out this vector AB. Now, what is OB vector? We have already assumed that OB vector corresponds to 2A vector plus 3B vector minus 4C vector. And from here, we're subtracting away vector. So that's negative A vector plus 2B vector minus 3C vector. Now let's simplify this by combining all the like terms. So 2A vector minus A vector will be positive A vector. 3B vector plus 2B vector will be positive 5B vector. Then we have negative C vector, negative 4C vector, and negative 3C vector will be negative 7C vector. So this is going to be our vector AB. We're going to label this as number 1 and keep it aside for the time being. Next, what we'll do, we will join B and C with the help of a vector going from B to C. And now we will try to find out the vector BC. So here we have OC vector minus OB vector. OC vector, that's negative 7B vector plus 10C vector. From here, we are going to subtract OB vector. So that's negative 2A vector, negative 3B vector plus 4C vector. Here we have negative 2A vector. We have only negative 2A vector. Then we have negative 7B vector combined with negative 3B vector to give us negative 10B vector. Then we have 10C vector plus 4C vector. So that's going to be 14C vector. So this is our vector BC. However, we can further simplify the vector on the right hand side. That means BC vector can be also expressed as if we take negative 2 as the common vector. So we have A vector plus 5B vector minus 7C vector. And here we can replace A vector plus 5B vector minus 7C vector with number 1. That means with AB vector, this will be equals to negative 2 times AB vector. Now, what we have shown here, since we have shown that BC vector equals to some scalar lambda times AB vector, where our value of lambda is negative 2. This simply tells us that the points A, B, and C, these 3 points must be collinear. So they are collinear in nature. So we've successfully proved the problem.